Okay, so this is lesson 8, adding and subtracting polynomials. We're going to be working on this the remainder of this week as well as in the beginning of next week. So adding and subtracting polynomials is basically like terms. So like terms, when we talk about like terms, they have the same variable and exponent. And you're going to hear me say combining like terms a lot, which is kind of exactly what this next one is. So when we add polynomials, we are just combining like terms. And again, like terms have the same variable and exponent. So if I was to give you an example of this, right, like terms could be x squared and 3x squared. Right, those are like terms. They have the same variable. They both have an x and they both have a squared as the exponent. That's what makes them like terms. Okay, and this is what we're going to work on today. We can actually combine these and condense them and make them smaller. One of the biggest things here is that your answers, when you're doing addition of polynomials or subtraction of them, is your answer should always be in standard form, which we did in lesson 7, which is highest to lowest exponents. Okay, so when you're looking here, you're looking for things that are the same, and you're going to see me use colors and shapes to kind of signify like terms here. So the first that I'm going to look for is my highest exponent, which in this case is x squared. So I see I have a 5x squared right here, and if I keep looking through the problem, I'm looking for all the x squareds, right? So I have 3. So technically I'm doing 5 plus 9 plus another 2. So 5 plus 9 is 14, plus 2 is 16x squared. So again, when you combine like terms, you do not change the exponent or the base. It's almost like you're just counting how many you have. So now if I switch colors just to show you, I have now my x's. So I'm going to do negative 3x, positive 7x, and a positive 7x. So I'm combining all 3 of those. So negative 3 plus 7 is 4x, and 4 plus 7 is 11x. And again, the x stays the same. You don't change the exponent. You just add the coefficients. So that might be something you want to add here, is the fact that when you're combining like terms, you only add the coefficients, which is the number in front. Okay, so that's the first example. So when we look at example 2 now, again, start with your highest exponent. So my highest exponent is the x squared, the 2, right? And then I want to combine those first. So 3x squared plus 7x squared is 10x squared. Okay, and then if I change to the next one, I'd be looking for the next highest exponent, which is just my x. So that's negative 5x and negative 6x. Combining those would give me negative 11x. And then I have my constants. So I have positive 4 and a positive 9, which would be a positive 13. So now we are in standard form. We have squared, a 1, and then a constant, and we can't combine anything else, so we're in simplest form. Notice here I had 3 different terms I was combining, so I have 3 different shapes. So sometimes you don't always have different colors available to you, so the shapes are helpful as well. Okay, so another way to write these is from top to bottom like this. So when you simplify and they're written on top of each other like this, some people think that this is easier. So you can visually see that these are my like terms right here. And then these are my other like terms right here. They're written on top of each other. So if we were to just straight up add these, 10r plus 7r is, 3r plus 10. I'm giving you guys the answers. 3r plus 7r is 10r, and 5 plus 3 is positive 8. Okay, so again, just another way to do this. This is helpful if you have every term matching up. A lot of people make mistakes with this if not everything has a pair. So we jump quickly into subtracting polynomials because the steps are basically the same as addition. There is one additional step, and it kind of is the exact same thing as what when we subtract integers. So you are going to use keep, change, and then you're just going to add polynomials, which is the same thing as combining like terms. So we do the same thing we just did in the previous problems, except we have this new first step of keep, change. Okay, so when we do this here, we have to keep in mind that we're going to be keeping the entire first part of this problem the same. So I'm going to keep 4z plus 7 all the same. I'm not changing that. So this is my keep. Okay, and I'm going to change this first subtraction to addition. And then I'm going to change all the signs in the second parenthesis. So this is a positive 6z, changing it to a negative 6z. That's a positive 1. I'm changing it to a negative 1. Now I'm at the same steps as I was before, just combine like terms. So highest exponent would be just the z. So 4z plus a negative 6z would be negative 2z. And then my constants, I have a positive 7 and a negative 1 to get a positive 6. So again, once you do keep, change, the steps are identical to what we did in examples 1 through 3. Okay, so here we're going to have a little bit more to work with. So if we do keep, okay, keep in mind we're keeping that entire first parenthesis the same. Right? Nothing changes in this first parenthesis. Nothing at all changes. Then we're going to change the subtraction to addition. And then we're going to change every sign in that second parenthesis. So that second parenthesis has 3 terms. Then I'm changing all 3 terms. So the positive 7x becomes a negative. The positive 5x squared becomes a negative. And the negative 12 becomes a positive 12. Now I can just combine like terms. So starting with my highest exponent, I have x cubed and a negative 7x cubed. So when I combine those together or add them together, I get a negative 6x cubed. Okay, then if I keep moving, I have a negative, I'll use circles here, 3x squared and a negative 5x squared. So a negative 3 plus a negative 5 is a negative 8x squared. And then I have a 5x plus nothing, right? There's nothing for me to combine with that. There's no other like term, so that just gets dropped down. And then I still have this plus 12 that I'm going to also just bring down. So I end up in this problem with 4 terms because 2 of them were not alike, so I couldn't combine them. Okay, example 6 has 2 different parts to it. So keep in mind that for this, you're only, because this one is subtraction and this one is addition, you have to only do keep, change to A and not B. So for A, if we do keep, change, we're going to keep the whole first parenthesis the same. right? So this whole first parenthesis stays the same. We're going to change the subtraction in the center to addition. And then we are going to change all the signs in the second parenthesis. So the minus 2w cubed would become a positive 2w cubed. The positive 4 would become a negative 4w squared. And the negative w would become a positive w. Okay, so once you do keep, change, now you're just combining like terms. So when we go to combine like terms, we start with our highest exponent. We have a w to the 4, which is our highest, and there is nothing for me to combine that with. So I'm just going to rewrite it below. Then I'm going to move to the next highest, which would be this 2w cubed, which again, I don't have anything to combine that with. So I'm bringing down positive 2w cubed. Okay, and then I move to the squareds. So I have w squared and a negative 4w squared. So if I combine them, I get negative 3w squared. And then I just have this plus w left. So again, I'll just kind of go through and fill in so you guys can see a clear visual of the answer, right? So again, I'm in standard form, highest to lowest exponent. I started with 4. I end up with a 1 for my exponent, right? And I combined anything that I could combine, and that's it. So for the next one, I do not have to do keep, change, and the main reason is because this is already a plus. So for this one, I'm just going to try to combine like terms. So again, starting with your highest exponent, I have g to the 4th, which I only have 1 of, so I can just bring that down. Then if I move along to the next highest, it would be g cubed, which I have 1 of also. So again, I'm just dropping that down. That was here. Now I have, it would be g squared, which I don't have any of, so that's not going to work. Then I have g, just plain old g, and I do actually have 2 of those. I have 12g and a negative 3g. So negative 3 plus 12 would be a positive 9g. And then I still have this plus 9 to bring down. So again, we couldn't combine much, only the g's. But again, it's condensed as much as, or simplified as much as it can be. So you're done. Okay, number 7 and has 2 examples again. And in red here, you'll see I wrote switch word. And the key being this word from. So remember that word from tells me to switch the position, right, of my 2 terms. So that means I'm taking this whole thing, 2x squared plus 3x, they are telling me I'm subtracting, and I'm switching it with this first 4x squared plus a 9x. Right, so the key word, again, is the fact that, 1, I'm subtracting, so you had to understand this was subtraction, and 2, the switch word is super important here. So because of that switch word, again, you have to switch the order of your polynomials. So now that I'm subtracting, I have to do keep, change. So I'm going to keep the whole first parenthesis the same. So 2x squared plus 3x stays the same. I'm going to change the subtraction to addition, and then I'm going to change all of these signs. So negative 4x squared that would become, and negative 9x that would become. Now I can just combine like terms. So like terms, I have 2x squared is my highest exponent I see, and I can combine that with a negative 4x squared. So 2 plus a negative 4 is negative 2x squared. Okay, and then I have 3x plus a negative 9x. So 3 plus negative 9 is negative 6x. So I'll just box this off because there's kind of a lot going on there. So that would be our answer. So now at this point, pause the video and try the next one because it's literally identical to this, it's just different numbers. You have the model right above it, so you could try it. Okay, so if you tried it, understand that you have a switch word, right? You are subtracting. You're taking this, though, and putting it first. And then you're going to take the first polynomial and put it second. And now you're just going to do keep, change, change. So we're going to keep it. So the whole entire first parenthesis, we're going to keep it the same. We're going to change this to addition. And we're going to change this entire second parenthesis to the different signs. So now we're going to combine like terms. So combining like terms, I have 3x squared and a negative x squared to get 2x squared. And then I have a negative 4x and a negative 3x, which is a negative 7x. Okay, so hopefully if you tried that on your own, you got it right. Okay, so this one was actually a Regents question, and it's actually on your test as well. It says if a is equal to 3x squared plus 5x minus 6. Oof. So they're telling you that this is what a is, and b is negative 2x squared minus 6x plus 7. So they're telling you what b is. Then they just want you to subtract these two things. So if you were to write it out, you would do 3x squared plus 5x plus 6 minus negative 2x squared minus 6x plus 7. So again, if you're subtracting, you're going to do keep, change, change. So this is going to be your keep. This will be your change. And this whole entire parenthesis will be your change. So the first parenthesis stays the same. Change your subtraction to addition. And then change all your signs in the second parenthesis. Now you just combine like terms. So I can start with my highest exponent, 3x squared plus 2x squared to get 5x squared. And again, if you use your answer choices to kind of eliminate, you can get rid of choice 1 and choice 3 because those have negatives. And then you have 5x plus 6x, which is 11x. So right then and there, you found your answer you don't even need to keep going. But if you did, a 6, and I wrote that down wrong. That should be a negative 6 here. Not a positive, so this would be a negative 6 that I'm combining, right, with a negative 7 to get negative 13, which is choice 2. Okay, so now you have your practice problem. So again, pause and try, and then move on from there. So these stay to simplify and write them in standard form. So combine what you can and make sure you're in standard form. So number 1, 2a cubed can be combined with another 4a cubed. They're like terms, a cubes. So it'll be 6a cubed. Okay, for the next one, start with your highest exponent. So I have 2x squared plus 3x squared would be 5x squared. And then 5x minus x would be a positive 4x. Okay, so far all you're doing here for these two is just combining like terms. Here, same thing, just combine like terms. They're both plus, right? So 8x plus 6x is 14x. And negative 12 plus a positive 9 is a negative 3. Okay, and the next one, I have 6d squared, and I'm going to combine that with 3d squared to get 9d squared. That's my highest exponent. Now I move on to d. Negative 2d plus 4d is a positive 2d. And then I have 5 plus a negative 6, which is just negative 1. Again, I'm using different shapes because I think visually it helps me. You can use colors if you have colors available, whatever works for you. Okay, so now we're going to do a couple where you have to determine if it's addition or subtraction. So for the number 5, we have subtraction in the center here. So this is keep, change, change. So if I keep the whole first parenthesis the same, I'm not going to change that. And change the middle to addition. And then change all the signs thereafter. Now I can combine like terms. So I only have 1 3a squared, so that comes down. Then I have a and negative 2a, which would be just negative 1a. And then I have 5 plus a negative 5, which cancel each other out. I'm sorry, that's a positive. Getting sloppy here, so this would not cancel out. So this is a positive 5 because I had to change the negative to a positive, and it would be a positive 10 then. Sorry about that. Okay. And the next one is just addition, right? So we're just combining like terms. So I'm going to start with my highest exponent, negative 4s squared, negative 2s squared. If I combine them, it's negative 6s squared. Moving along, I have 2s plus s, which is 3s. And my last one, I have a negative 3 and a positive 7, which is a positive 4. Okay, and then number 7 is back to subtraction. So keep, change, change. So I'm going to keep the whole entire first parenthesis the same. Change my subtraction to addition, and then change all the signs thereafter. Okay, and now we're going to look to combine like terms. So look for things that have the same base and same exponent. Highest one I see is a 3. So that's negative 10d cubed and negative 5d cubed, which would give us negative 15d cubed. If I look at my squared, I only have 1, so I'm just going to bring that down. Okay, then if I look for the d's, I have negative 3d and 6d, which would be a positive 3d. And then I can just bring down that plus 4 at the end. Okay, so that one was a little bit harder. You got a lot of work there. Make sure you get that down. Remember, your answer key is posted if you're struggling with keeping up, or just pause or stop the video. Okay, and then the last one is a challenge. So it says the fence around a quadrilateral-shaped pasture in total is 3a squared plus 15a plus 9 long. So that's the total perimeter. The 3 sides have the following lengths, which they're labeled. And it wants to know what is this length here. So if we know the total is 3a squared plus 15a plus 9, I can write that down, right? 3a squared plus the 15a plus 9. That's my total. And I can take away what I have currently. So if I combine like terms here, I have an a squared with nothing to combine with. I have 5a plus 10a is 15a. And then I have a negative 2 and a negative 7, which is a negative 9. So now what I could do is keep, change, change, and subtract what I know the total is minus the current sides I have. So if I do keep, change, change here, I would keep the whole first parenthesis the same. I would change the subtraction to addition, and then I would change all the signs in the second parenthesis. So when I do that now, I'm just combining like terms. So when I combine like terms, now I have 3a squared plus a negative 1a squared, because really there's a 1 here, to get 2a squared. Okay, and then I have a 15a plus a negative 15a. So those actually cancel each other out. And then I have 9 plus 9, which is 18. So my missing side here is just 2a squared plus 18. Okay, so that's the end of lesson 8. It is definitely a large lesson. It's probably going to be over 2 days. So watch the video, watch it over again if you need to. This is adding and subtracting polynomials.